Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving into the fascinating world of Java synchronization. We're currently in the fundamentals of concurrency season, exploring the chapter on synchronization fundamentals. In our previous episode, we covered thread basics, and now we're ready to tackle the synchronized keyword. Joining me as always is our Java expert, Victor. Hi, Victor.
Hello, Sheila, and hello to all our listeners. I'm excited to explore the synchronized keyword with you today. It's a fundamental concept in Java concurrency that every developer should understand.
Absolutely. Before we dive in, let's start with a quiz question for our listeners. Here's the question. What's the difference between using a synchronized method and a synchronized block in Java? And when would you prefer one over the other?
That's an excellent question, Sheila. It really gets to the heart of how to use synchronization effectively in Java. I'm sure our listeners will find it challenging but enlightening. Let's break it down a bit without giving away the answer. We're essentially asking about two different ways to use the synchronized keyword and their implications on performance and flexibility.
Great breakdown, Victor. Now, before we get into the details of synchronized, could you briefly explain what synchronization means in the context of Java programming? This will help set the stage for our listeners.
Certainly, Sheila. In Java, synchronization is a mechanism that ensures that only one thread can access a shared resource at a time. It's like having a single occupancy restroom in a busy restaurant. Only one person can use it at a time, preventing conflicts and ensuring orderly access.
That's a great analogy, Victor. So, with that in mind, can you tell us what the synchronized keyword does in Java?
The synchronized keyword in Java is used to create a synchronized block of code that can only be accessed by one thread at a time. It can be applied to methods or specific blocks within methods. When a thread enters a synchronized block, it acquires a lock on the specified object, and other threads must wait until the lock is released before they can enter the block.
I see. So, if I understand correctly, when we use the synchronized keyword, we're essentially creating a critical section where only one thread can execute at a time. Is that right?
That's exactly right, Sheila. The synchronized keyword helps us prevent race conditions and ensure thread safety when multiple threads are trying to access shared resources.
Interesting. Can you give us an example of how we might use the synchronized keyword in practice?
Certainly. Let's say we have a simple counter class that we want to make thread safe. We could use the synchronized keyword on methods that modify or access the counter. This would ensure that only one thread can change or read the count at a time, preventing any conflicts between threads.
That makes sense. But I've also heard about using synchronized on blocks of code within a method. How does that differ from synchronizing the entire method?
Great question, Sheila. Synchronizing a block of code instead of an entire method can be more efficient in some cases. When you synchronize an entire method, the lock is held for the duration of the method execution. With a synchronized block, you can limit the synchronized portion to only the critical section that needs protection. This allows other parts of the method to execute concurrently, potentially improving performance.
I see. So using synchronized blocks can potentially improve performance by reducing the time a lock is held. Are there any other advantages or disadvantages we should be aware of?
Absolutely, Sheila. While synchronization is crucial for thread safety, it does come with some trade-offs. Overuse of synchronization can lead to performance issues due to thread contention and potential deadlocks. It's important to synchronize only when necessary and to keep synchronized blocks as short as possible.
That makes sense. Are there any common pitfalls or best practices you can share with our listeners regarding the use of the synchronized keyword?
Certainly. One common pitfall is synchronizing on non-final fields. Since these can be changed, it might lead to synchronizing on different objects at different times, potentially breaking thread safety. It's generally best to synchronize on this or on a final object. Another best practice is to avoid calling methods that you don't control within a synchronized block, as this can lead to deadlocks if those methods also use synchronization. Lastly, remember that the synchronized keyword in Java provides mutual exclusion but not atomicity for compound actions. For complex operations involving multiple steps, you might need to consider using higher-level concurrency utilities from the java.util.concurrent package.
Those are really valuable insights, Victor. Now, I'm curious about how Synchronized compares to other synchronization mechanisms in Java. Could you briefly touch on that?
Of course, Sheila. While Synchronized is a fundamental and easy-to-use synchronization mechanism, Java also provides more flexible options like reentrant lock from the java.util.concurrent package. Reentrant lock offers features like timed lock waits and interruptible lock acquisition, which aren't possible with Synchronized. There's also the volatile keyword, which can be used for simpler synchronization needs when you're only concerned about variable visibility across threads and not mutual exclusion.
Thank you, Victor. That gives us a good overview of where Synchronized fits in the larger picture of Java concurrency. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, Sheila. The main difference between a synchronized method and a synchronized block is the granularity of the lock. A synchronized method locks the entire method, while a synchronized block allows you to lock only a specific section of code. You would prefer a synchronized block when you want to minimize the duration of the lock, improving concurrency. This is especially useful when only a small part of the method needs synchronization. On the other hand, synchronized methods are simpler to write and can be preferable when the entire method needs to be thread-safe or when the method is very short.
Excellent explanation, Victor. To summarize today's episode: 1. The synchronized keyword in Java is used to create thread-safe code sections. 2. It can be applied to methods or blocks of code. 3. Synchronized blocks offer finer granularity and can improve performance. 4. While essential for thread safety, overuse of synchronization can lead to performance issues. 5. There are alternatives like reentrant lock for more advanced synchronization needs. In our next episode, we'll be discussing object locks and reentrant locks, diving deeper into the world of Java synchronization. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the show. Your support helps us reach more Java enthusiasts. Until next time, happy coding.